Hello there, and welcome to the Sleepy Nature channel. Tonight, we're going somewhere very quiet and very beautiful. A place where ice turns the color of the sea, where glaciers glow from within like sleeping blue flames, and where the world feels ancient and still. Deep in Antarctica and Greenland, there is ice so old, so compressed, so perfectly layered that it shines turquoise, a soft, dreaming color between green and blue. Close your eyes for a moment and imagine that light. It is the color of calm. It is the color of rest. Take a slow breath in and let it go. You are safe. You are warm. And somewhere out there, a glacier is quietly glowing in the dark. There is a color that only very old ice can hold. It is not quite blue, and it is not quite green. It sits somewhere between the two, the way the sky looks just before a storm passes and the air becomes new again. That color has a name, turquoise, and it lives inside glaciers that are hundreds of thousands of years old, pressing down on themselves in silence, storing something ancient in every crystal. Imagine standing at the edge of one of those glaciers in Greenland. The ice rises above you like a quiet wall, taller than any building you have ever seen. It does not move. It does not speak. It simply is, blue-green and glowing softly, like a lamp someone left on in an empty room. The reason old glacial ice turns turquoise comes down to something very simple: air. When snow falls on a glacier, it traps little pockets of air between its flakes. For the first few years, the ice looks white, bright, and full of those tiny bubbles. But over decades, and then centuries, the weight of new snow pressing down from above squeezes all that air out. What remains is pure, dense ice with almost no bubbles at all. And pure ice, when light travels through it, absorbs the red wavelengths and lets the blue and green ones pass. This is the same reason the deep ocean looks dark blue. Pure water prefers those colors. The ice, without its air, begins to dream in turquoise. The oldest layers of a glacier, buried deepest, can be over 1 million years old. That ice has been pressing and compressing for so long that it is almost glass, a slow, cold glass that holds the memory of a world before humans existed. When scientists drill down into these layers, they find ancient air bubbles that were trapped long ago. Each one is like a tiny sealed room, holding a breath of air from another time. In Antarctica, the ice sheet is so vast that it covers an area larger than the United States and Mexico combined. In some places, it is nearly 5 kilometers thick. Imagine 5 kilometers of ice, layer after layer, year after year, one snowfall at a time. At the very bottom, the ice is so old and so compressed that it barely resembles snow at all anymore. It is slow and crystalline and faintly glowing. If you were to break off a small piece of glacier ice and hold it up to the light, you would notice that it feels heavier than regular ice from your freezer. That is because it really is denser. All that air has been pressed out over centuries of weight. It is the same water, the same molecules of hydrogen and oxygen, but arranged in a way that makes light move differently through them. When glacier ice melts in a glass of water, it makes a faint crackling sound. Tiny pops and snaps as those ancient air bubbles finally escape. They have been waiting inside the ice for thousands of years, and then, in the warmth of your kitchen, they release. It is one of the quieter sounds in the world, a kind of slow, small exhale. The glaciers of Greenland cover roughly 80% of the island. The island itself is enormous, the largest island in the world, but most of its land is invisible beneath ice that has been building up for millions of years. The ice sheet is a world all its own, with weather patterns, rivers of melt, and occasional blue pools forming on its surface in summer. Those surface pools are called supraglacial lakes. In summer, when the air warms just slightly above freezing, meltwater gathers in low places on top of the glacier, forming shallow lakes of the clearest, most vivid blue you can imagine. The water is so clean and so cold that it almost does not look real. It looks like something drawn in a dream. Sometimes those lakes drain suddenly, pouring down through cracks in the ice called moulins, vertical tunnels that carry meltwater from the surface all the way down to the base of the glacier. The sound of water rushing down a moulin is a deep, low rumble, like a river deciding to go underground. Then silence again. Antarctica is colder than Greenland, and its ice is even more still. The interior of the continent, far from the coast, receives almost no precipitation. It is technically one of the driest deserts on Earth, but what little snow does fall stays. It accumulates slowly, year by year, century by century, into ice that is quiet and ancient and perfectly layered. Scientists can read those layers like the pages of a book. Each year of snowfall leaves a faint line, a seasonal record. A warm summer shows up as a slightly different layer. A distant volcanic eruption leaves a thin mark of ash. Even a meteor impact on the other side of the world can leave a signature in the ice, a whisper of dust preserved for thousands of years. The ice near the coast of Antarctica is different. There, the glacier meets the sea and begins to float. These floating extensions are called ice shelves, and they are some of the most peaceful-looking places on Earth. Flat and white and impossibly large, stretching out over the dark Southern Ocean. In some places, the edge of an ice shelf rises 10 or 20 meters above the waterline, a vertical cliff of white and blue, constantly exhaling cold air into the sea wind. Where ice shelves meet the water, the sea sometimes carves caves and arches into the base of the ice. These underwater caves glow turquoise from above, lit by sunlight filtering down through the ice. If you could float through one of those caves, and some researchers have in small submarines, you would look up and see a ceiling of the softest, most luminous blue, like being inside a color you'd only imagined before. The turquoise light of glacier ice is not constant. It changes with the angle of the sun. In the long polar summer, when the sun never fully sets, the ice shifts through different shades throughout the day. Pale green at noon, deeper teal in the evening, almost violet when clouds pass overhead. At night, in winter, the ice sits in total darkness, holding its color inside, waiting for the light to return. If you feel ready, let your shoulders drop a little. Let your hands be still. Somewhere on the far side of the world, there is ice that has been quietly glowing for longer than anyone can remember. And it is not going anywhere tonight. There is a kind of silence that only exists where ice is very thick. It is not the silence of an empty room or a closed door. It is deeper than that. It is the silence of weight, of millions of tons of frozen water pressing down so slowly that no sound escapes, except perhaps a low, almost imperceptible groan from somewhere far beneath the surface. On the Greenland ice sheet, that silence is enormous. There are research stations up there, small clusters of buildings half buried in snow, and the scientists who work inside them say that when the wind stops, which does not happen often, the quiet is unlike anything else they have known. You can hear your own heartbeat. You can hear the faint sound of your breath. The ice sheet of Greenland was not always there. It built up slowly over millions of years, long before humans existed, when the climate shifted and snowfall began to stay, year after year, instead of melting. The very first layers, buried deepest now, closest to the bedrock, fell as snow during a world that was completely different from the one we know. Different animals, different forests, a different sky. Underneath the Greenland ice sheet, there is bedrock, and underneath some of that bedrock, there are ancient lakes, liquid water that has been trapped beneath the ice for millions of years, kept liquid by the geothermal heat coming up from the earth below. These subglacial lakes never see daylight. They are completely dark and perfectly still. The water in them has not been touched by the surface world for longer than humans have existed. Antarctica has many more of these hidden lakes. Lake Vostok, buried nearly 4 kilometers beneath the East Antarctic ice sheet, is one of the largest. It is roughly the size of Lake Ontario. Scientists drilled down to reach it after decades of effort, and when they did, they found the water was clean and cold and very, very old. They had to be careful not to disturb it, not to introduce any contamination from the surface world. The idea of a lake that has been sealed beneath kilometers of ice for millions of years is something worth sitting with for a moment. All that time, just water, still, dark, patient, waiting. On the surface of Antarctica, the wind can do extraordinary things to ice and snow. Sastrugi, that is the word for the ridges and waves that wind carves into the surface of polar snow, can make the landscape look like a frozen sea. Low, smooth waves of hard-packed snow, sometimes just a few centimeters tall, sometimes rising to knee height, all pointing in the same direction, shaped by the same wind that has been blowing across that plain for centuries. Walking across Sastrugi is a particular kind of walking. You lift your feet a little higher, you watch where you step, and the sound is a soft crunch with each footfall. Not like fresh snow, which squeaks, but like compressed, almost chalky snow that has been through many freeze-thaw cycles and hardened into something nearly mineral. The ice in Antarctica is not all the same color. Near the surface, where fresh snow has fallen recently, it is brilliant white, so bright that you need eye protection to look at it directly in sunlight. Deeper, where the ice has been compressed and the air bubbles have been squeezed out, the color begins to shift. By the time you reach very old ice, it is a steady, deep turquoise, the color that lives only in things that have been patient for a very long time. There are icebergs too, pieces of glacier that have broken away from the main ice sheet and float out into the ocean. Some icebergs are enormous, the size of small countries. They drift slowly northward, melting as they enter warmer water. Their massive underwater bodies, about 90% of the iceberg is below the surface, grinding silently through the dark sea. The part of an iceberg you can see is always the youngest, freshest ice, white or pale blue. But sometimes when an iceberg rolls, which they do slowly, over days or weeks, as they melt unevenly and their center of gravity shifts, the older, deeper ice comes to the surface, and that ice is turquoise. A roll of the ice in the middle of the ocean can reveal a color that has been hidden for thousands of years. In Greenland, the people who have lived near glaciers for generations, the Inuit, have their own relationship with ice. Their languages have many words for different kinds of ice and snow, each describing a specific texture, age, or behavior. There is ice you can walk on and ice you cannot. Ice that has good light and ice that is dangerous at night. Ice that makes sounds and ice that stays quiet. This is not because they are unusual. It is because knowing ice meant survival, and language grew to fit what was needed. The word for a particular shade of blue-green in Inuit languages, the color of old, dense glacier ice, carries a meaning that is not quite translatable into English. It is somewhere between the color itself and the feeling of standing in front of something that has existed longer than memory. If you feel your breathing slowing a little, that is exactly right. You do not have to do anything with that. Just let it slow. When you look closely at a piece of very old glacier ice, really closely, the way scientists do with instruments that can see individual crystals, you find that it is not made of one big solid block. It is made of countless tiny crystals, each one a perfect structure of hydrogen and oxygen, all interlocking with each other, all slightly different sizes, all fitting together like a puzzle that has no visible seams. Over time, as the ice sits under pressure, those crystals slowly rearrange themselves. They grow. The smaller ones are absorbed by the larger ones. After thousands of years, a piece of glacier ice might have crystals the size of your palm, enormous by the standards of regular ice. These giant crystals are part of why old glacial ice looks so clear and so luminous. The light has fewer internal surfaces to bounce around in, so it travels deeper before it reflects back. And the deeper it goes, the bluer it gets. If you enjoy the channel and find it helps you drift off, feel free to like the video. It helps more people find their way here. No rush whenever you feel like it. Glaciers do not stay still. They move. Very slowly, a few centimeters to a few meters per day, depending on the glacier. But they move. The weight of the ice above pushes the ice below forward, toward the coast, toward lower ground, toward the sea. A single snowflake that falls in the interior of Greenland today might, over thousands of years, travel all the way to the coast and finally break off into the ocean as part of an iceberg. Its entire journey from cloud to ocean might take 100,000 years. That slow movement is not silent. Deep inside a glacier, the ice creaks and groans under its own weight. Sounds that travel through the ice for kilometers before they fade. Researchers who lower microphones down into glaciers describe a constant, low-frequency murmur, a kind of long, slow conversation the ice is having with itself. Not loud, not sharp, just a steady, deep sound, like a very large, very slow heart. In Antarctica, some glaciers flow fast enough to be called ice streams. These are rivers of ice, kilometers wide, that flow toward the coast much faster than the surrounding ice. Not meters per day, but sometimes hundreds of meters per year. The fast movement creates stress fractures, and those fractures create crevasses, deep blue cracks in the surface of the glacier, sometimes just a few centimeters wide at the surface, but opening up to meters wide just below. A crevasse in glacier ice is one of the bluest things in the world. The opening is narrow, and the light that enters it bounces between the two walls, losing its red wavelengths with each reflection, until by the time you look down into the deepest part, you see only the deepest blue, a color like something the ocean dreamed. The bottom of a deep crevasse disappears into a blue so dark it is almost indigo. The wind in Antarctica can reach extraordinary speeds. Near the coast, katabatic winds, cold, heavy air flowing down from the high interior plateau, can gust to over 300 kilometers per hour. When that happens, the snow is lifted from the surface and carried horizontally, and the world becomes pure white movement. Nothing else exists but the cold and the sound. But between storms, the air in Antarctica is some of the clearest on Earth. In winter, from the polar plateau, the sky is so clear that stars look different, brighter, more precise, as if someone had cleaned the glass between you and them. The Milky Way stretches overhead in a ribbon of cold light, and below it, the ice reflects the stars, so that on a still night, you might feel like you are floating between two skies, one above and one below, both full of quiet light. The aurora australis, the southern lights, appears over Antarctica in winter when particles from the sun interact with the Earth's magnetic field and create curtains of colored light above the pole. Green is the most common color, but sometimes red and sometimes blue, and sometimes a soft, wavering teal that looks almost exactly like the color of the glacier ice below. In those moments, the sky and the ground are the same color, the same patient, glowing turquoise, one ancient and frozen, the other alive and moving. Greenland's aurora is called the aurora borealis. People have been watching it from that island for thousands of years. The Inuit had stories about what the lights were. Some said they were the spirits of the dead playing a game with a walrus skull. Others said they were living things, and that you could call them closer by whistling softly. Whether or not that is true, there is something beautiful about the idea that you could have a conversation with the sky, and the sky might answer. Let yourself be heavy now. Let the weight of your body settle. Somewhere far away, the sky is green and moving, and the ice below is still. The snow that falls in Antarctica is not like the snow that falls in a city. There are no big, wet flakes. The air is too cold and too dry for that. Antarctic snow falls as tiny, hard crystals, almost like dust. In some parts of the continent, these crystals are so fine and so dry that they stay on the surface for years without bonding together, shifting in the wind like a dry powder, never quite settling. This kind of snow is called diamond dust when it falls from a clear sky. Small ice crystals form in the air, even without clouds. When the air is cold enough and still enough, moisture condenses directly onto tiny particles of dust and falls as a faint, almost invisible shimmer in certain light, usually early morning or evening when the sun is low. Diamond dust catches the light and makes the air sparkle, not dramatically, not the way fireworks do, more like the faintest silver haze, as if the air itself has decided to shine a little. The ice core records that scientists pull from glaciers are among the most detailed climate archives we have. A single core drilled from the Antarctic ice sheet can contain a record of the last 800,000 years of climate history. 800,000 years of temperature, snowfall, volcanic eruptions, and atmospheric composition, all stored in layers of ice thinner than a sheet of paper. Reading those records requires patience. Scientists look at the ratios of different oxygen isotopes in each layer. Slightly heavier and slightly lighter versions of the same oxygen atom, whose proportions change depending on how warm or cold the climate was when the snow fell. A warmer year leaves a slightly different chemical signature than a cold one. By reading thousands of these signatures, one layer at a time, they can build a picture of what Earth's climate looked like long before any human was alive to see it. There is something deeply calming about that idea, actually. All of that history, all of that time, held quietly in the ice, waiting, patient, ready to be read by someone with the right tools and enough curiosity. The meltwater lakes that form on the surface of glaciers in summer are not just beautiful to look at. They support life. Bacteria and algae can survive in those cold, clear pools, turning the ice around them faint shades of pink or green. These microorganisms are some of the hardiest living things on Earth, able to survive temperatures near freezing, intense ultraviolet radiation from the sun, and a complete lack of nutrients from the surrounding ice. Some species of algae that live on glacier ice produce a pigment that turns the snow red, a phenomenon called watermelon snow. When you walk through it, it smells faintly sweet, like the fruit it is named after. Scientists think the pigment might protect the algae from ultraviolet radiation, acting like a kind of sunscreen. It is life finding a way in one of the most inhospitable environments on the planet, doing it quietly, doing it in color. Penguins live near the coast of Antarctica, but not on the ice sheet itself. They need the sea, but they do walk across sea ice, the frozen ocean, to reach their breeding grounds, and those walks can be remarkably long. Emperor penguins, the largest species, walk sometimes 100 kilometers across sea ice in the middle of winter, in the dark, in temperatures that can reach minus 60 degrees Celsius with wind chill, and yet they do it calmly. Emperor penguins huddle together in large groups during the worst storms, rotating slowly so that each bird takes a turn on the cold windward edge and then moves back to the warm center. The huddle itself generates heat, and the birds move through it in a slow, quiet wave, inward and outward, always rotating, always together. There is a kind of wisdom in that movement, not dramatic, not hurried, just a slow, constant adjustment toward warmth. The sea ice around Antarctica is different from the glacier ice. It is formed from frozen seawater, not from accumulated snowfall. When seawater freezes, it expels most of its salt. The ice is never as salty as the ocean, though it carries some saltwater pockets trapped inside it. The ice that forms from the sea is gray-white and relatively thin, a meter or two thick in most places, compared to the kilometers of ancient ice inland. But thin as it is, sea ice changes the entire character of the ocean around Antarctica. It reflects sunlight back into the sky, cooling the region. It creates habitat for krill, small, shrimp-like creatures that feed on the algae that grows on the underside of the sea ice, and which are, in turn, the foundation of the entire Antarctic food web. Without sea ice, the krill would struggle. Without krill, everything that eats krill, penguins, seals, whales, would feel it. The underside of Antarctic sea ice, seen from below, is one of the most beautiful and alien places in the ocean. The ice forms a ceiling of pale green and white light, filtered through just a meter of frozen ocean, rippled and textured by the movement of water and the growth of ice crystals from below. Divers who have been there describe it as looking up at a frozen sky, cold and luminous and impossibly still. Let the weight of all that stillness come to rest in you. Let your breath move slowly like the tide beneath the ice. The fjords of Greenland are among the most magnificent natural features on Earth, and yet most people have never seen them. They are long, narrow arms of the ocean that cut deep into the island's coastline, carved by glaciers over millions of years, slowly, methodically, grinding rock into smooth, curved valleys that the sea then filled when the ice retreated. In summer, those fjords are filled with floating ice, not just small pieces. There are icebergs in the Ilulissat Ice Fjord, one of the most productive glaciers in the world, that are the size of apartment buildings. They drift slowly through the fjord, impossibly blue-white, making no sound at all from a distance, though up close they pop and hiss and crack as the compressed air inside them slowly releases. The glacier that feeds the Ilulissat Ice Fjord, called Sermekkujalik in Greenlandic, moves so fast that it produces roughly 40 billion tons of icebergs per year. That sounds like an enormous number, and it is. But the glacier itself is so vast that the calving of icebergs from its face barely seems to affect it. One day, there is a wall of ice, and the next day, a piece the size of a skyscraper simply leans forward and falls into the water. A deep, booming sound. A wave. And then the fjord is a little more crowded with ice, and the glacier face is already beginning to grow back. If you have enjoyed the story so far, the playlist has many more like this one. Oceans, forests, mountains, and stars. It is always there when you need it. The light in Greenland in summer is strange and beautiful. Because the sun never fully sets for months at a time, the quality of light is constantly shifting, but always present. The sun moves in a low circle around the horizon, and for hours each day it casts long, golden light across the ice and water, a kind of perpetual late afternoon warmth that makes everything glow. The shadows are long and soft. The ice turns from white to gold to pink as the sun moves. In winter, of course, the opposite is true. The sun disappears entirely for weeks, and Greenland sits in a kind of deep blue twilight. During the midday hours, the sky lightens to a dark, extraordinary blue, not the blue of a summer sky, but a richer, denser blue, like the inside of a glacier. The snow reflects this color and becomes blue itself. The whole world turns blue for a few hours each day, and then goes dark again. There are communities in Greenland, small towns on the western coast, where people live alongside this cycle of light and dark in ways that have not changed much in generations. Houses painted in bright colors, red, yellow, green, stand out against the snow and ice. Tiny warm sparks of color in a landscape that is mostly white and blue and gray. The settlements near the ice have access to fresh meltwater, cold, clean water that has spent thousands of years inside the glacier before flowing out into streams and rivers in summer. This water is so soft and so pure that it has almost no taste at all. It is the taste of nothing, which is its own kind of perfection. The Greenlandic language, Kalaallisut, has a word, Nanunartok, that roughly means the place that resembles a polar bear. It describes a landscape that is white and textured and vast, a place where you might easily lose track of where the land ends and the sky begins. That kind of landscape, snow stretching to the horizon in all directions, is difficult to describe to someone who has never seen it, but the feeling of standing in it is something many people who have described as unexpectedly peaceful. There is nowhere to be, nothing to do, just the cold and the light and the endless, quiet white. Musk oxen live in Greenland, large, shaggy animals that look like they belong to an earlier age of the world. They have survived in the Arctic for over 600,000 years, living on the sparse grasses and mosses that grow in summer and enduring winter on the energy reserves they built up during the warmer months. They move slowly, calmly, in small herds, their thick coats blocking even the most violent polar winds. The underfur of a musk ox, called kiviut, is one of the warmest natural fibers in the world, 8 times warmer than sheep's wool. It is shed naturally in spring, and people in Greenland and Arctic Canada collect it and spin it into yarn for clothing. A garment made from kiviut is extraordinarily light and soft, almost impossibly warm for how little it weighs, like holding a cloud that had decided to become a sweater. Let your eyes close now if they haven't already. There is nothing that needs your attention tonight except the slow and patient beauty of a world that has been here much longer than any worry you are carrying. The icebergs that break off from Greenland's glaciers travel a long way. Carried by the Labrador Current, they drift southward along the eastern coast of Canada, past Newfoundland, sometimes as far as the Grand Banks. By the time they reach those warmer waters, they are much smaller than when they started. Weeks or months of melting have worn them down, but they are still extraordinary things. Blue-white towers of ancient ice, floating in an ocean that is slowly dissolving them. Sailors have watched icebergs for centuries with a particular kind of respect. They are unpredictable. They roll without warning as they melt unevenly. And when an iceberg rolls, the underwater section that was previously submerged surfaces suddenly, often covered in a vivid, deep turquoise color that takes your breath away. That turquoise is the old, compressed interior of the glacier, ice that has not seen daylight in 10,000 years, suddenly exposed to the Atlantic sky. The sound of an iceberg in the ocean is a steady dripping and a faint, constant hiss, the sound of compressed air escaping as the ice melts, releasing those ancient bubbles in a slow, continuous whisper. If you put your ear to a piece of glacier ice, you can hear it. A faint crackling, a tiny pop, a small release. The sound of something very old letting go, very gently. The Arctic Ocean around Greenland is not empty. It is full of life that has adapted to the cold and dark in extraordinary ways. Bowhead whales, enormous, slow-moving animals with thick layers of blubber, live their entire lives in Arctic waters. They can live for over 200 years, making them among the longest-lived animals on Earth. Some bowheads alive today were born before the American Civil War. They carry within them a kind of living history of the Arctic that is impossible to fully comprehend. Arctic cod live beneath the sea ice, feeding on the krill and amphipods that cluster on the underside of the frozen ocean. They produce a kind of natural antifreeze protein in their blood that keeps their cells from freezing in water that is below 0 Celsius. Their bodies have found a way to be comfortable in a place that would otherwise be lethal. A quiet, elegant solution that took millions of years to arrive at. Narwhals swim in the fjords of Greenland in small groups. their long spiraled tusks breaking the surface occasionally when they come up to breathe. Those tusks, which are actually extended teeth with hundreds of thousands of tiny channels connecting the surface to a network of sensory nerve endings, can detect changes in temperature, water pressure, and salinity. The narwhal feels the water it swims through with its tusk the way you might run your fingers along a surface to understand its texture. The ringed seal is the most common seal in the Arctic and one of the most adaptable. It maintains breathing holes in sea ice throughout the winter, scratching through the ice from below to keep the holes open as the ice thickens. Polar bears, standing motionless above these holes for hours in the cold, wait for the seals to surface. It is one of the most patient acts in the natural world, a stillness that lasts hours in temperatures that would defeat most living things. But tonight, we are not thinking about that. We are thinking only about the ice and the water and the slow turning of the world in cold and light. The light that filters through sea ice into the water below shifts with the seasons. In spring, when the ice is thinning and cracks begin to form, more light enters the ocean. Algae that have been waiting on the underside of the ice through the dark winter months suddenly begin to bloom in enormous quantities. A spring bloom so dense that the water turns green for hundreds of kilometers. This bloom of life beneath the melting ice is one of the most important events in the Arctic ecosystem. Everything depends on it. There is a kind of patience in the algae too, waiting through the long dark, not giving up, just waiting for the light to come back because it always does. The ice on the surface of Greenland's fjords in early spring, before the main melt begins, is called fast ice because it is fastened to the shore. It does not drift. It does not move. It just sits there between the land and the sea, holding the cold and the quiet for a few more weeks before the summer begins to take it apart. Walking on fast ice in spring, something Greenlandic hunters have done for thousands of years, requires knowing how to read it. You look for the texture, the color, the sound it makes when you tap it. Thick, safe ice is dark blue-gray. Thin, unsafe ice is pale, almost white. Old, reliable ice has a matte surface. New, dangerous ice has a glossy sheen. The ice tells you what it is, if you know how to listen. Let your thoughts grow quiet, like that ice. Still, patient, holding the cold and the dark and the waiting for light, without rushing any of it. There is a glacier in Greenland called Helheim, named, perhaps too dramatically, after the Norse realm of the dead. But there is nothing frightening about it in reality. It is a wide, slow river of ice that flows from the high interior of the island down to the coast, where it pushes out into a fjord and calves icebergs almost continuously. From above, from satellite images, it looks like a white river flowing toward the sea, its surface broken into ridges and pressure features that from ground level would look enormous, but from the air look like fine texture on a piece of cloth. Many of Greenland's glaciers have local names given to them by the Inuit over generations. These names describe things: the color of the ice in a particular light, the sound the glacier makes in summer, the way it looks from a certain hill at a certain time of year. A glacier is not just a mass of ice. It is a landscape feature with character, with history, with a presence that deserves a name. In Antarctica, Most glaciers are named by the expeditions that first surveyed them. Names from the heroic age of polar exploration, Scott, Shackleton, Amundsen, appear on maps of the continent, alongside the names of ships, scientists, and geographic terms. But the glaciers themselves are older than any of those names. They were there long before anyone came to name them, and they will remember those names only for as long as the names are used. The thing about Antarctic glaciers is that their size is genuinely difficult to hold in your mind. The Lambert Glacier, the largest in the world, is over 400 kilometers long and 100 kilometers wide. It drains a basin of ice roughly the size of Western Europe, slowly carrying that ice toward the coast, where it becomes an enormous floating ice shelf. The movement is quiet and gradual, a few meters per year in the slow-moving sections, faster near the coast where the ice flows more freely. But over millions of years, that movement has carved the continent and shaped the ocean. Deep beneath the Antarctic ice, there is bedrock that no one has ever seen directly. In some places, the weight of the ice above has pressed the land down below sea level. The rock of Antarctica is actually below sea level in places, held down by the weight of ice above it. If the ice were removed, the land would slowly rise back up, a process called isostatic rebound. But it would take thousands of years. The Earth is patient, but not in a hurry. The air above the Antarctic plateau is the cleanest air on Earth. There is almost no particulate matter, almost no pollution. The nearest industrial activity is thousands of kilometers away, on other continents. Scientists who study air quality sometimes come to Antarctica not to measure pollution, but to establish what truly pristine air looks like, a baseline for comparison with everywhere else. Breathing that air, researchers say, feels different, not dramatically. You do not feel superhuman or transformed, but there is a clarity to it, a kind of lightness that is hard to describe. It is like the air itself has more room in it, like each breath takes you slightly further than usual. The midnight sun of an Antarctic summer means that the light at 2 in the morning looks exactly like the light at 2 in the afternoon. The sun traces its low circle around the sky without ever dipping below the horizon. Many people who work at Antarctic stations say they lose track of time in this light, not in a disorienting way, but in a peaceful way. The usual rhythm of dark and light, which tells you when to rest and when to be awake, simply stops. You sleep when you are tired and wake when you are rested. The light is always there, patient and steady. The ice at the surface of the Antarctic plateau has a particular texture in sunlight. It is not smooth. Wind has carved it into intricate patterns, ridges, hollows, tiny wavelets of hard-packed snow. In the right light, these patterns cast shadows that make the surface look like a topographic map of some unknown country, all in white and pale blue and shadow. You could walk for hours across it, and the texture would keep changing. The wind has been working on it from different directions at different times, and the results are endlessly varied. There are places in Antarctica where the ice has been blown away completely and bare blue ice is exposed. These are called blue ice areas, and they are perhaps the purest expression of what turquoise ice really is. The ice is old and dense and almost translucent. In sunlight, it glows with a deep, steady blue-green light. It is not reflective. It does not shine like a mirror. It glows from within as if there is a very gentle lamp somewhere deep inside. Feel that color in your mind now, if you can, the deep, steady blue-green of ice that has been patient for a very long time. Carry it with you into sleep. The Southern Ocean that surrounds Antarctica is the wildest ocean on Earth. It has no continental boundaries to slow it down. It circles the globe completely, driven by some of the strongest winds anywhere, generating waves that can be 10 or 15 meters tall. Ships that cross it do so with respect and preparation, but closer to the continent, sheltered somewhat by the land and ice, the water calms. In the bays and inlets near the coast, the water can be startlingly still, especially in early winter when new sea ice is beginning to form. The ice forms first in thin, translucent sheets, so thin you can see the dark water beneath them. This new ice is called nilus, and it has a strange quality. It bends. Unlike thick sea ice, nilus flexes with the movement of the water beneath it, rising and falling gently with small waves, rippling slightly at its edges. It looks almost soft. As it thickens, nilus ice becomes gray and then white, losing its translucency but gaining strength. The transition from fragile, bending nilus to solid white sea ice takes only a few days in cold enough temperatures. The ocean seals itself for the winter in a process that is much faster than you might expect. The formation of sea ice changes the chemistry of the ocean water below. When seawater freezes, the salt it expels sinks into the water below, making that water denser and heavier. This cold, salty water sinks all the way to the ocean floor, where it spreads slowly across the bottom of the world's oceans. Antarctic bottom water, as it is called, can be traced in the deepest parts of every ocean on Earth. Evidence of a process that has been cycling cold, dense water from the poles to the rest of the ocean for millions of years. The world's oceans are connected in this way. Water that froze in Antarctica thousands of years ago is now slowly circulating through the deep Pacific, the Indian Ocean, the North Atlantic. The oceans breathe in a way, inhaling cold at the poles and exhaling it, warmed, back into the surface waters of the tropics. The cycle takes about 1,000 years to complete. In Greenland, the same process happens in the North Atlantic. Cold, dense water from the Arctic sinks near Greenland and Iceland and flows southward along the ocean floor. This sinking drives the Atlantic meridional overturning circulation, the system that includes the Gulf Stream, which keeps Western Europe much warmer than it would otherwise be. The warmth of a winter in London or Paris is, in a small but real way, connected to the cold of the water sinking near the Greenlandic coast. Everything is connected, the ice and the ocean and the wind and the warmth. All one long, slow conversation that the planet has been having with itself for billions of years. The stars above the Antarctic plateau in winter are extraordinary. The atmosphere there is so thin and dry and clean that the seeing, as astronomers call the clarity of the night sky, is among the best in the world. Telescopes have been installed at the South Pole Station specifically to take advantage of this clarity. The cosmic microwave background, the faint glow of radiation left over from the beginning of the universe, has been mapped in exquisite detail from instruments looking up through the Antarctic winter sky. There is something remarkable about that. Instruments sitting on ice that is 3 kilometers thick in the coldest place on Earth looking back through time to the beginning of everything. The oldest light in the universe, meeting some of the oldest ice on the planet, in the darkest place on Earth. From the surface, though, you cannot see the telescopes easily. What you see is the sky, immense, black, filled with more stars than seem real. The Milky Way is not a faint smudge here. It is a river of light, thick and detailed, crossing the entire sky, from horizon to horizon. If you lie down on the ice and look straight up, it feels like falling into it, like this story is slowly, gently pulling you somewhere quiet, like you're falling very slowly into the soft dark. That is exactly right. Let it happen. There is a moment in the deep Antarctic winter when the light on the horizon, the sun has not risen above the horizon in weeks, but its glow is still faintly visible, turns the sky the exact same color as the glacier ice below. Everything is turquoise. The sky and the ice and the air between them are all the same pale, glowing blue-green, and for a few minutes it is impossible to tell where one ends and the other begins. People who have been at Antarctic stations in winter describe this moment with unusual consistency. They do not say it is dramatic. They say it is quiet, deeply, profoundly quiet. The kind of quiet that stays with you. The Antarctic ozone layer, the layer of ozone molecules high in the atmosphere that filters ultraviolet radiation from the sun, was found to be thinning over Antarctica in the 1980s due to certain chemicals released by industrial activity elsewhere in the world. Scientists working at Antarctic stations in the 1970s and 1980s noticed the change first. Strange measurements that nobody expected from instruments that were designed to detect something ordinary. The thinning ozone became one of the first global environmental problems that humanity successfully addressed through an international agreement to stop producing the responsible chemicals. The ozone layer has been slowly recovering ever since. The story of the ozone layer is often told as a crisis story, but it can also be told as something else. A quiet, careful attention to something most people had never thought about, followed by a slow, patient recovery. The layer is still there. It is still recovering. It is doing it without any fanfare, just gradually, year by year, a little less thin, a little more whole. The ice cores that scientists pull from Antarctica contain a record of this too. The chemicals that damaged the ozone layer left a signature in the ice. So did the moment their concentrations began to fall after the international agreement took effect. The ice remembered. Snow petrels, small entirely white birds, breed in Antarctica, nesting in rocky outcrops near the coast. They have been seen flying over the interior of the continent, hundreds of kilometers from the nearest open water. Nobody is entirely sure why they fly so far inland. There is nothing for them to eat there, no shelter. Perhaps they are just flying. Perhaps the interior of Antarctica is, for a snow petrel, simply a place to be in the wind. They are pure white, these birds, except for their small black eyes and small black bill. In flight over the ice, they are almost invisible, a white shape moving through white space. You see them only when the angle of the light is right, or when they pass over a shadow. For a moment, you see a bird, and then the light shifts, and it is just ice and sky again. The Wilson's storm petrel also breeds in Antarctica, making it one of the most numerous birds in the world. In summer, Millions of them are scattered across the Southern Ocean, skimming the surface of the water with their feet dangling, picking up tiny crustaceans and bits of fish. They are small, about the size of a sparrow, but they travel enormous distances. Some storm petrels banded in Antarctica have been recaptured in the North Atlantic. A sparrow-sized bird crossing an ocean. There is a research station on the Antarctic Peninsula, the arm of land that juts out toward South America, called Palmer Station. It is one of the smaller American stations, home to a few dozen researchers in summer and a skeleton crew in winter. It sits on a rocky promontory surrounded by glaciers, and from its windows in winter, you can watch the glaciers glow in the long polar twilight. The researchers there often describe the silence, not as empty, as full, a full silence, the sound of wind across ice, the creak of the building in the cold, the distant, occasional sound of an iceberg calving somewhere in the bay. These sounds exist inside the silence, not against it. Remember, you can always come back to this playlist whenever you need to find that silence again. It will be here. The turquoise color of old glacier ice is not just beautiful. It is, in a way, functional. The dense, bubble-free ice absorbs sunlight differently than white, aerated ice does. It absorbs the red and yellow wavelengths and reflects the blue-green ones. And because it does this so selectively, it warms more slowly than white ice would. White ice reflects most sunlight back into the sky. Turquoise ice absorbs some wavelengths and reflects others, reaching an equilibrium with the sunlight around it that is different from the surface ice above. This is one of many small, intricate ways in which the physics of ice is more complex than it first appears. Ice is not just frozen water. It is a material with its own properties, its own way of interacting with light, with pressure, with temperature, with time. In Greenland, scientists have found ancient ice at the bottom of deep drill cores that was formed during periods of very different climate. The ice from the last ice age, which ended about 12,000 years ago, is different from the ice formed in warmer periods. You can see the difference in the cores, different crystal sizes, different oxygen isotope ratios, faint differences in color. The ice from the last ice age is slightly whiter because during that cold period, dust and sea salt carried by powerful winds was deposited on the ice sheet in much larger quantities, and that dust is still in the ice, preserved for millennia. The ice from the warm periods between ice ages, called interglacials, is slightly clearer and denser, less dust, slower, quieter snowfall, a calmer climate. The ice remembers these things. On the surface of the Greenland ice sheet, in summer, a network of rivers and streams forms from meltwater. These are not small trickles. Some of them are dozens of meters wide and fast-moving, carving channels into the ice before suddenly disappearing down a moulin. The water is so cold that it runs clear as glass, and the channels it cuts into the ice are smooth and curved like the inside of a bowl. Occasionally, these surface rivers form frozen waterfalls, places where meltwater that was flowing during the day freezes overnight as temperatures drop, creating intricate curtains of ice draped over the lip of a crevasse or a ridge. By morning, when the sun warms things again, the frozen waterfall begins to melt and the water runs again. This daily rhythm of freeze and flow creates extraordinarily detailed ice structures, honeycomb textures, rippled surfaces, delicate overhangs that catch the morning light and throw it back in pale blue. The meltwater streams on the Greenland ice sheet eventually all find their way to the edges of the ice sheet, where they flow off the glacier either through moulins or over the edge of the ice as waterfalls that cascade down the margins of the glacier. These waterfalls carry enormous quantities of fine glacial flour, rock ground to powder by the glacier's movement over bedrock. And when this flour reaches the ocean, it gives the fjord water a characteristic blue-gray, milky color that is completely different from the clear water further out at sea. Where these two waters meet, the milky glacial runoff and the clear ocean water, you can sometimes see a visible line in the water. On one side, blue-gray and opaque. On the other, dark and clear. The two waters do not mix immediately. They run alongside each other for a while, a visible boundary, before turbulence and current gradually blend them. There is something almost meditative about that boundary. Two things, side by side, different, not yet mixed, comfortable with the difference. The Greenland shark is one of the strangest creatures in the Arctic Ocean. It is the slowest fish in the world. It moves at less than a mile per hour. It lives at enormous depths, in waters near freezing, and it lives for a very, very long time. Scientists have found Greenland sharks that they estimated to be over 400 years old, possibly as old as 512 years, making them the longest-lived vertebrates known to science. A Greenland shark alive today was a juvenile in the 1600s. It has lived through centuries of change in the Arctic, the Little Ice Age, the Industrial Revolution, the modern era. It has never been in a hurry. It moves through the cold, dark water at a pace that is barely a movement at all, finding food, surviving, and simply continuing to exist in the deep and the cold. There is something to learn from a Greenland shark, not about everything, but about patience, about taking up space in the world without rushing, about the deep cold and the dark as something you can live inside, slowly, for a very long time. When scientists talk about the silence of deep ice, they sometimes use the word acoustic. The ice is acoustically quiet. Sound travels differently through ice than through air or water. In dense glacier ice, sound waves that enter from the surface are absorbed or scattered by the crystal structure, and by the time they have traveled any distance, they are much diminished. The deep ice is not just quiet in the way a room is quiet. It is quiet in the way a material is quiet. Sound simply does not move easily through it. This means that the very oldest, deepest ice, the ice that is closest to the bedrock, 1,000,000 years old or more, has never heard anything. Not the wind at the surface, not the creak of the glacier above. It is insulated from all of that by kilometers of material that does not let sound through easily. It sits in a perfect, permanent acoustic silence, in the cold and the dark, undisturbed. The idea of that is extraordinary if you let yourself sit with it. Something that has existed for 1,000,000 years and has never heard a sound. The tidewater glaciers of Greenland, glaciers whose faces extend into the ocean, are constantly calving, not dramatically most of the time. Most calving is quiet at the waterline, where the warmer ocean water melts the ice from below faster than the cold air does from above. The ice becomes undermined, and eventually a piece breaks off and floats free. But occasionally, a larger section lets go all at once, and there is a sound like distant thunder, a low, rolling boom that travels across the fjord and echoes off the stone walls on either side. After the sound, a wave. Not huge, but significant, enough to rock small boats moored at a distance, enough to disturb the ice floating in the fjord. And then, gradually, things settle back to stillness. The new iceberg bobs gently in the water, already beginning to melt, its fresh, calved face a startling white against the blue-green of its older sides. The flora of Greenland, the plants that grow in the ice-free parts of the island, is sparse but beautiful. Arctic cotton grass grows in marshy areas near glaciers, producing white, fluffy seed heads that bob in the wind. Dwarf fireweed blooms in vivid pink in summer. Crowberries and blueberries grow close to the ground, their leaves turning brilliant red in autumn before the snow returns. These plants have adapted to the short growing season by doing everything quickly and efficiently. They flower within days of the snow melting, produce seeds rapidly, and often have specialized mechanisms for trapping heat near the ground. Hairy stems, bowl-shaped flowers that track the sun, low-lying growth forms that stay below the worst of the wind. Everything about them is practical and quiet and competent. Arctic willows, the smallest trees in the world, grow in Greenland in a most unusual way. They grow horizontally along the ground, their branches spreading outward rather than upward, so that the whole plant stays below the height where the wind would damage it. A mature Arctic willow might cover a square meter of ground, but stand only a few centimeters tall. If you stretched its branches out straight, they might be a meter or more in total length. But because they grow sideways, the plant is nearly invisible until you are right next to it. This horizontal growth is sometimes called a prostrate habit, and it is a very effective strategy. The plant gets the same amount of sunlight as it would if it grew upright, but it avoids the wind and cold that come with being taller. It stays close to the warmth of the ground, which absorbs heat from the sun in summer and releases it slowly overnight. The soil near the surface in Greenland's ice-free areas can be several degrees warmer than the air above it, and the prostrate willows live in that thin band of relative warmth. If you were to lie down on a patch of Arctic tundra in summer, something researchers sometimes do just to experience it, you would feel that warmth. The ground, dark from absorbed sunlight, is noticeably warmer than the air. It smells of moss and old soil and something mineral and clean. Above you, the sky is enormous. Below you, the ancient rock of the Canadian Shield or the Greenlandic gneiss, some of the oldest rocks on Earth. And all around you, growing close to the ground, the small, patient, horizontal willows. The turquoise ice on the surface of Greenland's glaciers sometimes forms in a way that makes it look lit from within. In certain conditions, usually in the hour after sunrise or before sunset, when the sun is low and the light is almost horizontal, the ice seems to glow with an internal luminescence that has nothing to do with a reflection from the sky. The light enters the ice at a shallow angle and travels through it before emerging, changed. The red wavelengths are absorbed, the blue and green ones continue, and the ice glows turquoise from the inside, like a lamp. Photographers who have seen this phenomenon describe it in almost identical terms, regardless of where they encountered it. They say it looks as though someone placed a light source inside the glacier. They say it is the most beautiful thing they have seen. They say they stood there longer than they intended to. The ice caves of Iceland, not quite Antarctica or Greenland, but still glacial, still ancient, offer a similar experience. There are caves inside Vatnajökull, the largest glacier in Iceland, that can be entered in winter when the meltwater has drained and left a system of tunnels and chambers inside the ice. The ice on the walls of these caves is thousands of years old, dense and compressed and blue-green. The light that enters through the ice above filters down into the cave and fills it with a diffuse, sourceless glow. Not bright, not dramatic, but extraordinary, like standing inside a color. The walls of a glacier ice cave are not smooth. They are textured. You can see the layers of ice year by year, like the rings of a tree. You can run your hand along the wall and feel the subtle ridges where one annual layer meets the next. Summer ice and winter ice are slightly different in density and texture, and that difference has been preserved for thousands of years. The wall of the cave is a timeline you can touch. The cold inside a glacier cave is different from the cold outside. It is very still. There is no wind. The temperature is constant, usually just below freezing. The ice does not melt here in summer. The cave is insulated by the massive glacier above it, and the temperature inside stays stable year-round. It is one of the most thermally stable environments on Earth, less variation in temperature than almost anywhere else, including the deep ocean. Caves in the ice of Antarctica are even more extreme. Some ice caves in Antarctica have never been visited by humans. They exist beneath the ice, formed by volcanic heat from below and filled with warm, moist air that creates an ecosystem of its own. Mosses, bacteria, possibly more. Scientists who have mapped these caves without entering them, using remote sensing equipment lowered through holes drilled in the ice above, have found evidence of photosynthesis, evidence that plants are growing in a warm, dimly lit space beneath the Antarctic ice, somewhere above a volcanic heat source. The imagination does something quiet and wonderful when you picture that. A warm cave full of mosses beneath kilometers of ice at the bottom of the world. A small, green, living place in the middle of all that cold and stillness. Life finds the warmth. Life finds the light. Life does not particularly care how strange the place is, as long as those two things are present in some measure. The midnight sun in Greenland can make sleep difficult for visitors who are not used to it. But the residents, the people who have lived through many summers of endless light, have their own ways of settling into sleep. Dark curtains, routines that signal the body that it is time to rest. The rhythm of the body's own clock, maintained even without the cue of darkness. And sometimes just the sound of the wind moving across the ice, or the distant creak of a glacier, or the soft sound of meltwater running somewhere nearby. These sounds are old and ordinary and entirely trustworthy. They have been happening here for thousands of years. They will continue. There is a process that happens inside glaciers called regelation, and it is one of the quieter miracles of physics. When pressure is applied to ice, when the glacier pushes against a rock or an obstacle, the pressure lowers the melting point of the ice slightly. The ice melts just a little, just at the point of contact. The meltwater flows around the obstacle, and then, on the other side, where the pressure is lower, it freezes again. The glacier has, in a sense, flowed around the rock without ever fully becoming liquid. It has simply decided, in the most minimal way possible, to be briefly water and then to return to being ice. This is how glaciers move over bedrock, not dramatically, not with violence, by briefly, softly, becoming something else at the points of friction, flowing past and becoming themselves again. A kind of patient, physical intelligence. The bedrock beneath glaciers is shaped by this process and by simple abrasion. Rock carried within the base of the glacier, pieces of stone frozen into the ice, drags across the bedrock below and carves grooves and striations into it. These grooves all point in the same direction, the direction the glacier was moving. Long after the glacier is gone, the grooves remain in the rock. They are called glacial striations, and they let geologists read the direction of ancient glacier movement from exposed rock faces thousands of years after the ice has retreated. Walking across a landscape that was glaciated in the past, much of northern Europe, Canada, northern Asia, you are walking across a surface that was shaped by ice. The smoothed, rounded hills are called drumlins. The long ridges of deposited rock are moraines. The deep, U-shaped valleys are glacial troughs. The landscape you walk through today was drawn by ice, slowly, over tens of thousands of years. The last ice age ended roughly 12,000 years ago. At its peak, ice sheets covered much of northern Europe and North America. The Scandinavian ice sheet was 3 kilometers thick over what is now Stockholm. The Laurentide ice sheet covered most of Canada and extended into the northern United States. The weight of these ice sheets pressed the land down, and as the ice melted, the land began to rise back up. That rise is still happening. Stockholm is rising about 5 millimeters per year, lifted by rock that is still slowly bouncing back from the weight that was removed from it 12,000 years ago. The ground is patient. The land remembers the ice. In Greenland today, a similar process is happening in miniature. As the ice sheet loses mass, which it has been doing for decades, the land beneath it is rising. GPS measurements at bedrock sites beneath the ice show the rise clearly. The rock of Greenland is slowly emerging from beneath its icy blanket, millimeter by millimeter, year by year. The emergence of new land from beneath retreating ice is called deglaciation, and it creates extraordinary habitats. The rock that emerges is bare at first. No soil, no plants, nothing but fresh stone. But within years, the first organisms arrive. Lichens, those patient, slow-growing partnerships of fungus and algae, establish themselves first, beginning the work of creating soil from rock. Then mosses, then flowering plants. Then, over decades and centuries, shrubs and trees. The oldest life on Earth, not in terms of the age of the species, but in terms of the age of individual organisms, includes lichens. Some lichen colonies are estimated to be thousands of years old. They grow so slowly that their increase in size each year is barely measurable, but they grow, quietly, steadily, making soil from rock, preparing the ground for everything that comes after. There is a beautiful, slow progression in that. Bare rock, lichen, moss, grass, shrub, tree, each one preparing the way for the next, without any urgency. The land does not rush into becoming a forest. It takes its time. The stars above Greenland in winter, the ones that are visible during the brief midday twilight and brightly visible in the long polar night, include some of the same stars that sailors used for navigation across the North Atlantic for centuries. Polaris, the North Star, sits almost directly above the North Pole, and in Greenland it is high overhead, higher than it appears from lower latitudes. For Greenlandic sailors and hunters, it was a fixed point in a turning sky, something that could always be relied upon, something fixed, something constant, something you can return to whenever you need to find your bearings. The ice of Greenland and Antarctica is the largest freshwater reservoir on Earth. If all of it were to melt, which would take a very long time, many centuries, the global sea level would rise by roughly 65 meters. This is not something that will happen tonight or in our lifetimes. But it is a fact that gives a sense of scale to how much water is locked up in ice at the poles. Most of the world's fresh water is in ice. Rivers, lakes, and underground aquifers hold only a small fraction of the total. The glaciers and ice sheets hold the most. This means that the turquoise ice we have been thinking about tonight, the dense, compressed, ancient ice of the great ice sheets, is not just beautiful. It is an enormous part of how the world holds water. The snow that falls on Antarctica today will, in its own time, become part of that turquoise ice. First, it will be fresh, light, white powder. Then, it will be compressed by the snow above it into firn, a halfway state between snow and ice, granular and dense, opaque. Then, over hundreds of years, it will be compressed further into true glacier ice, its air squeezed out, its crystals growing large, its color shifting slowly from white to blue. The turquoise is not a fixed thing. It is a stage in a long, slow process of becoming. Everything is in the process of becoming something else. The ice is becoming water. The water is becoming ice. The rock is becoming soil. The soil is becoming forest. Nothing is still, even when it appears to be. The sounds of a glacier are not all low and distant. In summer, meltwater running over the surface of the ice makes high, clear sounds. The same sounds as any running water, but purer, because the water is so cold and so clean. A stream running across glacier ice sounds like a mountain creek, except that the channel it runs through is pale blue instead of stone gray, and the water is so cold that it numbs your hand in seconds. The ice in an Antarctic glacier is so old that it contains water molecules that have been frozen since before the last ice age. Some of the water molecules in the deepest layers have been part of the ice sheet for 1 million years or more. They have cycled through snow, ice, ocean, cloud, and back to snow more times than can be counted. But their last residence in ice has been very long, a very long stay in one form. The penguins of Antarctica have a particular sound when they are settled together in their colonies. A constant, low murmur of soft calls, individual voices blending into a collective sound that from a distance resembles the sound of a gentle crowd in a warm room. Up close, each call is distinct. Parent calling to chick, chick calling back, the same sounds repeated until the recognition is made and they find each other in the crowd. Emperor penguin chicks, when they are very small, ride on their parents' feet, tucked under the belly, staying warm in the cold. The parent stands over the chick like a small house, and the chick fits underneath perfectly. The chick can hear its parent's heartbeat from there. It does not need to do anything except stay warm and wait while the adult keeps it safe. There is something deeply comforting about that image, something held, something warm and safe and still, something that does not have to do anything except exist, right where it is. The lights on the Greenland ice sheet at night, the lights of the research stations, are very small in a very large darkness. From far away on the ice, a research station looks like a handful of lit windows in an enormous black field. The generators hum quietly inside. The scientists eat dinner, or sleep, or check their instruments, or look out at the darkness thinking their own thoughts. And all around them, for hundreds of kilometers in every direction, the ice is silent and ancient and glowing very faintly in the starlight, blue-green in the dark. If you have found the channel recently, the playlist has many more stories, each one a different quiet place in the natural world. Feel free to explore it when you need a peaceful hour. There is a last kind of turquoise ice that is worth knowing about. It occurs at the base of icebergs, just at the waterline, where the ocean is slowly dissolving the oldest, densest part of the ice. At this zone, where the ancient interior of the glacier meets the sea, the ice is most deeply turquoise. It is the compressed heart of the glacier, exposed at last to air and water, softly glowing with the color it has been holding for 10,000 years. This zone is called the waterline zone, and it melts faster than the ice above or below it, because the ocean water is warmer than the iceberg interior. As it melts, it reveals layer after layer of old ice, each one slightly older than the last, each one a little denser and a little bluer. The iceberg is very slowly turning itself inside out as it melts. The youngest ice on the outside goes first. The oldest, innermost ice is the last to disappear. The turquoise is the last thing to go. When that ice finally melts into the ocean, the molecules of water, frozen for 10,000 years, join the sea. They become part of the North Atlantic Current, part of the next evaporation, the next cloud, the next rainfall over some continent we cannot predict. They might fall as snow somewhere again, years from now, and begin the long process of compression once more. The ice does not end. It only changes. The research stations of Antarctica will close for the winter soon, emptied of most of their summer researchers, left with a small crew who will spend the dark months maintaining equipment, running experiments, keeping the lights on. They will watch the aurora from their windows. They will hear the wind. They will be some of the most isolated people on Earth, in some of the most beautiful surroundings. And the ice will not notice. The ice does not need anyone to watch it to continue being what it is. In Greenland, the fjords will freeze. The surface meltwater streams will become ice again. The supraglacial lakes, which were vivid blue turquoise in summer, will freeze over and become indistinguishable from the glacier surface. The ice will thicken at the edges and hold everything in a still, cold embrace until spring. The light will return. It always does. The aurora will cross the sky in curtains of green and teal, and the ice will reflect it dimly, and the stars will continue their slow rotation around the pole, and the Greenland shark will continue its slow journey through the deep, dark water, unhurried, ancient, patient. And somewhere deep inside the ice sheet, 2 kilometers down, or 3, or 4, a crystal of ice the size of your palm will sit in perfect silence, carrying within it a memory of sunlight and air and snowfall from before any city existed. It does not know you are here. It does not need to. It is simply there, blue-green and still, holding its time and its color and its cold, doing what ice does, being patient, being quiet, being beautiful in the dark. Let yourself be still like that now. Let your breath be slow and easy, not because you are trying to make it slow, but because your body knows what to do when you stop asking it to hurry. Let the turquoise color settle somewhere behind your closed eyes, that soft, ancient blue-green that belongs to the oldest ice in the world. You are warm. You are safe. The world is very large and very old and mostly quiet. And tonight, right now, you are held inside all of that quiet like an emperor penguin chick under a wing. Small, warm, not needing to do anything at all. The ice is still glowing somewhere far away, and you can sleep now.